Hello, everyone. Example 1-3 is about energy equation. So a rectangular channel has a width of 3.5 meter and carries a flow discharge of 8.12 cubic meter per second with a depth of 1.545 meter. So if I draw the channel cross section, so we have a rectangular channel and it has a width of 3.5 meter. And then the water depth in the channel is 1.45 meter. So this is the channel width and channel depth. And it goes through a smooth and a small hump with a flat top to build the bed and increase the bed elevation by 15 centimeter. So if I draw the channel section, so we have a smooth change. And then we have the water surface. So we know that the water depth here at this point is 1.45 meter. And then the elevation change is also 0.15 meter. We also know the discharge is 8.12 cubic meter per second. Okay, so the question asks us to calculate the water level after the transition. So we don't know what is the water level here. So we can use the combination of energy equation and continuity equation. The first step is to set up a datum line. So I use this as datum. So we have two sections, section 1 and section 2. So let me move this one a little bit down here. So I call this section 1, and then here section 2. And we know that the continuity equation Q1 is equal to Q2. Therefore, in rectangular cross section, we have V1 B Y1 is equal to V2 B Y2. And I can also write the energy equation. So energy equation tells me that Z1 plus Y1 plus V1 squared divided by 2G is equal to Z2 plus Y2 plus V2 squared divided by 2G. And we always have energy loss. But in our case, we assume that the energy loss is negligible, so it's 0. Okay, now I can use continuity equation and replace with the discharge. So replace velocity with discharge in the energy equation. So I can rewrite energy equation in form of Z1 plus Y1 plus Q squared divided by 2G B Y1 square is equal to Z2 plus Y2 plus Q squared divided by 2G B Y2 square. Okay, so in energy equation, Z1 and Z2 are known. Z1 is 0 and Z2 is 0.15 meter. Y1 is given, Q is given, B is given, So the only unknown is y2. So I have one equation, one unknown. So I'm going to replace the values. So 0 plus 1.45 plus 8, 1, 12 square divided by 2 times 9.81 times 3.5 times 1.45 square is equal to 0.15 plus y2 plus 8.12 square divided by 2 times 9.81 times 3.5 y2 square. So we have one equation, one unknown, and then we can rearrange this equation and solve for y2. So you calculate the left-hand side, and then you multiply the right-hand side by y2 square, and then you will get y2 to the power of 3 minus 1.43 y2 square plus 0.27 is equal to 0. So always energy equation gives you a cubic equation, which you can solve it with your calculator. And the cubic equation gives you 3 roots. So we have y2 equal to 1.255 meter. y2 is equal to 0.56 meter. And then y2 is negative. So we always discard the negative answer, and we always have 2 positive answers. One is larger compared to the other one. So the larger depth is always called the subcritical answer. And then the shorter depth, the shallower depth is supercritical. So in future lectures, we'll find out that subcritical flow remains always subcritical, and supercritical flow always remains supercritical, unless you have hydraulic jump or flow over weir. So we don't have any hydraulic jump or flow over weir. So in that case, we need to calculate the Froude number to find out whether the flow is subcritical or supercritical. In rectangular cross-section, Froude number is equal to V divided by square root of GY. So I can also multiply that by the area, basically, to have discharge Q divided by BY1 square root of GY1. So 8.112 divided by 3.5 times 1.45 times the square root of 9.81 times 1.45. So that gives you 0.42, which is less than 1. So the flow is subcritical. So the flow is subcritical and it remains subcritical. So we choose subcritical answer. So the supercritical answer is not correct. Okay, that's it.